Good afternoon. Myself Vaishnavi. I am going to present about network topologies. The topologies in general are the physical layout in which of the network in which the components of the network, which we call as nodes, are connected to each other, and that defines topology. Objectives: describe the basic and hybrid LAN physical topologies, their uses, advantages, and disadvantages. Describe the backbone structure that form the foundation of most of the LAN. LAN first located network. Simple physical topology. Physical topology. Physical layout of nodes on a network. So topology, as I said, it's just the interconnection of network. So physical topology means physical layout of the nodes. There are mainly four fundamental shapes in which the topology exists: bus, ring, star, and mesh. These are the fundamental shapes, but there are more than this. May create hybrid topologies. So with these fundamental shapes, hybrid topologies are also created. Topology integrates type of network, cabling infrastructure, and transmission media used. So these factors are the major components of a topology, like the type of network, cabling infrastructure, transmission media. Why we need a topology? Choosing one topology over another can impact type of equipment that network needs, capabilities of the equipment, network's growth, where a network is managed. So depending upon these criteria, we have to choose what type of topology that we need. So this is a layout of a bus. As you can see, there are different nodes connected. Here, the data is shared through the backbone. As you can, the central wire is connecting all the other nodes in the system. And there is a terminator and a grounded terminator. Simple physical topologies like bus topology consists of a single cable called a backbone. As you can see in the figure, this cable connects all the nodes in this topology without intervening connectivity devices. There is no other connectivity devices rather than the nodes that are connected to the network. Devices share responsibility for getting data from one point to another. So suppose a device wants to share a message to another device. Within the device, communication happens when no other extra like components are placed, only the device exists in the topology. Terminators stop signals after reaching end of wire, prevent signal bounce. Like terminators, as you can see, there are terminators kept at the end, and they are used to stop when the signals reach the end of the wire to prevent signal bounce. It is comparing to other topologies, is very inexpensive and is not much scalable, difficult to troubleshoot, and not fault tolerant. And here are the advantages as well as disadvantages. Advantages: works well for small networks. So basically, bus topology is used mainly for small networks. As you can see, because a single wire connects all the other devices. And it's very easy to install because only small components are used and it's just a single cable is needed to connect all the other devices. Relatively inexpensive because of the same reason. Disadvantage: management costs can be high. Network disruption when computers are added or removed. Because when some computers are added, like when since all the messages, all the components are connected to each other. When suddenly another component comes, it will be difficult for the carriers to send the message. A break in the cable will prevent all systems from accessing the network, and it's very difficult to troubleshoot. Second topology is ring topology, and this is the way how the topology exists. Each node is connected to the two nearest nodes to the entire network forms a circle. Like as you can see in this figure, each two nodes are connected to each other. Like that's how it forms a circle, and that's how it's called a ring topology. One method for passing data on ring network is token passing. So this is the way in which the data are being carried from one node to the other, and that's known as token passing. Because each system which wants to send data carries forward a token, That's how this works. Data travels around the network. Traffic flows in one direction. Since it is a ring topology, obviously traffic can flow only in one direction, and it's very slow performance. One workstation goes down, whole network goes down. Network is highly dependent. So since this is a ring topology, if one system failure occurs, it affects all the other system in the topology. Since it is in a circular, it's formed in a circular fashion, and network is highly dependent on each other. Here are the advantages and the disadvantages. Advantage: cable poles are easily located, making troubleshooting easy. Compared to bus topology, ring topology, here cable poles are easily located, but in bus topology, it's not easily located, and even troubleshooting is easy. In bus, it's hard. Ring networks are moderately easy to install. Now, disadvantages: it's very expensive because the topology is in a circular fashion, requires more cable and network equipment at the start. Expansion: comparing to bus topology, it requires more cable and network equipment. Expansion to the network can cause network disruption. A single break in the cable can disrupt the entire network. So these are the disadvantages. Next is the star. As you can see, star topology, where it forms a structure because a central hub connects all the other components of the network. Every node on the network is connected to a central device called hub or switch. Here, you can use either hub or a switch. The only difference between those is switch contains more ports compared to hub, wherein hub generally it contains 2 ports. So in this figure, they have kept a switch because it contains many ports. Any single cable connects only 2 devices. Cabling problems affect 2 nodes at most. So in this case, only 2 or 1 nodes will be affected if there is any kind of cable problems because it's directly connected to the hub and not any other nodes. Requires more cabling than ring or bus networks. It's more fault tolerant compared to bus, and star is more fault tolerant, easily moved, isolated, or interconnected with other networks. Scalable, support maps of 124 addressable nodes on logical network. Now here are the advantages and the disadvantages. Good option for modern networks, low startup cost, easy to manage, offers opportunities for expansion, most popular topology in use, wide variety of equipment available. Disadvantage: hub is a single point of failure because if hub fails, the whole topology gets disrupted because hub connects all the other network. Hub connects all the other components or the nodes of the network. So if hub fails, definitely everything gets disrupted. The whole topology gets disrupted. Requires more cable than the bus. And this is mesh topology, which is the most reliable topology out of every other topology. Here, each node is connected to every other nodes in the network. That's the specialty of mesh topology. Each computer connects to every other. High level of redundancy, because of which high redundancy occurs, because that everything is interconnected. So same data may appear in other computers or other systems or other nodes also. It is rarely used. These are the reasons that it is rarely used, because wiring is very complicated, cabling cost is very high, troubleshooting a failed cable is tricky, a variation hybrid mesh create point-to-point connection between specific network devices, often seen in WAN implementation. So mesh topology is basically used more in WAN topology rather than the LAN or PAN or any other topologies, because of the fact this is connected to every other node and it's quite complicated. These are the advantages and the disadvantages. It's robust. There is advantage of privacy security. Since each node is connected to other nodes, like there is an advantage of privacy. The network can be expanded without destruction to current users. Point-to-point links make fault identification and fault isolation easy, because it's a point-to-point dedicated channel goes through that. The fault tolerant or everything, like what if a fault happens, it's very easy to identify that. Disadvantages are that requires more cable than other LAN topologies. By the figure itself, we can understand like there a lot of cabling is required for the mesh topology, and hence it has a complicated implementation. Installation and reconnection are difficult. Sheer bulk of wiring can be greater than the available space can accommodate. Because if the space is small, but we have to go for bulk of cabling, which is hard, and hence it is very expensive. Now, hybrid topology. So as I said before, hybrid topology is a combination of different topologies like star and ring or ring and bus, everything together, which forms a hybrid topology. And one example of hybrid topology is tree topology. So tree is a combination of bus and star topology. It consists of groups of star configured workstations connected to a linear bus backbone cable. So here the bus backbone cable acts as a bus topology, and then the star topology is connected to that linear cable. So if that backbone line breaks, the entire segment goes down. An example of this network could be cable. Like if that single bus topology, we are using that cable, and if that goes down, the entire network, topology gets disrupted. Now, choosing a topology. Like, why do we want to choose a bus topology? Because the network is small, will not be frequently reconfigured, least expensive, is not expected to grow much. So if we have to choose a small location or small connectivity, then we go for bus topology, then the network is small. And it's very less expensive compared to all the other topologies. And then star. Why do we go for star? Star topology. It must be easy to add or remove pieces. In star topology, it's very easy to add or remove the pieces or the nodes connected because only the central hub parts a major role, right? The cabling goes only to that their ports, and hence if one component goes down, it's easy to remove that component from that because it's connected to only that hub or switch. And it doesn't affect the network at all if one or the other is disrupted. Now it must be easy to troubleshoot, and it is easy to troubleshoot. Network is large, is expected to grow in future. Why do we go for ring topology? Network must operate reasonably under heavy load. So in case of heavy load, what happens when heavy load of data appears? At that time, we can go for ring topology. Higher speed network is required. When we need high speed network, at that time also we go for ring topology because it only single node is connected to the other two nodes, so that it's easy. When we need high speed network, we go for ring topology. And also the other reason is that here the network will not be frequently reconfigured because of the fact that we use a bit of large amount of cabling, so it's not reconfigured just as in star. So that's it. That's what topology is all about. Thank you.